So once we've gone through the balancing equations and we have figured out that our mole ratios, we can actually get into the reagents and percent yield form of this. So when we look at it, a limiting reagent is a substance in a reaction that gets used up first. An excess reagent is something that you have more than you need. It's not something that will end up. So for example, reactant A in test 2 is in a test tube. We have 20 of them. Reactant B is the stopper. If I have 30 of them, which product is a stopper test tube? How much can product be made? What is the limiting reagent? So we have to go through which one is going to be used up first, which one is going to be excess. That's what we're looking at. So percent yield is going to deal with theoretical versus practical. So theoretical is using your the amount that you're supposed to have when you calculate it. Practical, or what you are doing, is something that you have already done. It's what you're going to actually use. And so your percent yield figures out how much you actually use based on that theoretical and practical yield. So if I want to go through, I can figure out how much my percent yield is of this particular equation. So lead nitrate equals lead oxide plus nitrogen dioxide and then oxygen. So what we're going to figure out is which one is going to yield what. So we're given the specific grams of lead nitrate, so we have to go from lead nitrate to get to our moles. We go from our moles to our mole ratio between nitrogen dioxide and lead nitrate, and to get that into what our percentage is going to be. So once we find it out, we take what we know, we find our molar mass of lead nitrate to figure out how many moles we will have. So now we have to figure out how to get from our lead nitrate to nitrogen dioxide. And so by doing that, we take our molar ratio, which we see is 4:2. Since we're going to nitrogen dioxide, we want to get rid of the moles of lead nitrate. So this is where physical method is going to work the best. So we're going to take this, cross these out. We have gotten rid of lead nitrate from the organization. We're trying to figure out what our yield is going to be. So we're now into our moles of nitrogen dioxide. We want to get to grams, so we have to find our molar mass of nitrogen dioxide to figure out what our percent yield is going to, or what our theoretical yield is for this. This is what you should get if everything is perfect. Percent yield is your actual yield divided by your percent yield, or basically figuring out a theoretical yield. It is the amount formed during the reaction that is not the same as the theoretical. Your percent yield uses efficiency, so it is the percent. So it is your actual divided by your theoretical times 100, of course. So we're taking what our actual is and dividing it by our theoretical. So if you were to start with 1.2 grams of aluminum, what is the theoretical yield of aluminum? If I only have if only 7.5 grams are created, what is the percent yield? So if I were to go through, I would find out that there are 18.1 grams of the theoretical yield, but I only made 7.5 grams of the yield of actual yield. So I take my 7.5 divided by my 18.1 multiplied by 100. So I have only created 41.4% of what I actually could, of what the theoretical yield should be. Is this very good? Not really. What I am looking for is I'm trying to find the combination of the two. Now, with this particular thing, with this particular idea, we are having to go through the stoichiometry to get to our percent yield that we are looking at, so what our actual and theoretical yield are. So this is a very long multi-step problem. We will go through all of this together and make sure we get it done the right way. All right. Now, if you have any questions, please ask in class. This is for extra help only. So please watch these if you need extra help or if you are missing class. If you are having more trouble, please reach out to me and we will do our best to get together in class or at lab or on a Wednesday. All right. Have a nice day.